The iodide ion reacts with hypochlorite in the following way. OCl minus plus I minus, you get OI minus plus Cl minus. So the rate law for that would be the rate law. Rate is equal to the rate constant K times the concentration of the first reactant OCl minus raised to its order m times the concentration of the second reactant I minus raised to its order n. So we need to determine K, m, and n. So we need to form three equations, and those equations will come from the three runs. So this is run 1, run 2, run 3. Let's analyze run 1. So rate is equal to K times OCl to the m, I to the n. So let's plug in the values. For run 1, the rate was 1.36 times 10 to the negative 4 is equal to K times, what is OCl? 1.5 times 10 to the negative 3. This is raised to m. And what is I minus? 1.5 times 10 to the negative 3 as well, raised to the n. Next, let's analyze. So this now is our equation 1. Equation 1. Let's analyze run 2. Run 2, the rate was 1.3. I'm sorry. The rate was 2.72 times 10 to the negative 4 is equal to K times OCl was 3.0 times 10 to the negative 3 raised to the m. And what was I minus? 1.5 times 10 to the negative 3 raised to the n. And this now is our equation 2. Let's analyze run number 3. Run 3. The rate was 2.72 times 10 to the negative 4 is equal to K times OCl was 1.5 times 10 to the minus 3 raised to the m. So 1 point, and then I minus is 3.0 times 10 to the minus 3 raised to the n. This now would be our equation 3. Okay, so we need to solve for K, m, and n. So what is the plan? Plan, if you divide equation 2 by equation 1, you can solve for m. Solve for m. Step 2, if you divide equation 3 by equation 1, you can solve for n. For n. And once you have m and n, you substitute m and n in equation 1, and then you solve for k. Solve for k. Alright, so that is the plan. So let's get to work. Let's do step 1. Step 1. Step 1, divide equation 2 by equation 1. So let's rewrite equation 2. 2.72 times 10 to the negative 4 equals K times 3.0 times 10 to the minus 3 to the m, 1.5 times 10 to the minus 3 raised to the n. We divide equation 2 by equation 1, and equation 1 is 1.36 times 10 to the minus 4 equals k times 1.5 times 10 to the negative 3 raised to the m times 1.5 times 10 to the negative 3 raised to the n. What do we get now? K cancels, 1.5 times 10 to the negative 3 raised to the n cancels, and we are left with 2.72 divided by 1.36, that will be 2. And this is 3.0 times 10 to the negative 3 over 1.5 times 10 to the negative 3, and they are both raised to the power m. What is 3 over 1.5? That will be 2 to the m. So 2 is equal to 2 to the m. It follows that m is equal to 1. Next, step 2. Step 2 is divide equation 3 by equation 1. So equation 3 is 2.72 times 10 to the minus 4 equals k times 1.5 times 10 to the negative 3 to the m times 3.0 times 10 minus 3 raised to the n divided by equation 1. 1.36 times 10 to the minus 4 equals k times 1.5 times 10 to the negative 3 raised to the m 1.5 times 10 to the negative 3 raised to the n. So k cancels, 1.5 times 10 to the minus 3 raised to the m cancels. 2.72 over 1.36 is 2. And this is 3.0 times 10 to the minus 3 over 1.5 times 10 to the minus 3. And both are raised to the m. So that will be 3 over 1.5 again is 2. So 2 to the m. So 2 to the n rather. N. 2 is equal to 2 to the n. It follows that n is equal to 1. Step 3. Step 3. Substitute m and n in equation 1, solve for k. So we have to rewrite equation 1. 1.36 times 10 to the negative 4 equals k times 1.5 times 10 to the negative 3 raised to the m. But what is m? It's 1. Times 1.5 times 10 to the negative 3 raised to the n. But what is n? It's 1. So we have one equation, one unknown. We solve for k. If you do it right, k is equal to 60.44. So to answer the question, the rate is equal to k 60.44 times OCL raised to the m, which is 1, times I minus raised to the n, which is also 1.